Arafat Musaleh, and this is my presentation for class CIS 476. I'm going to talk about the prototype pattern that's in the design patterns. So let's get started. First of all, what is the prototype patterns? Prototype design pattern is a creational design pattern which is used when a prototypical instance determines the type of objects that will be created. It is mostly used to avoid subclasses of an object creator in the client application and to avoid the inheritance cost creating a new object in the standard way when it's prohibitively expensive for a given application. The client, instead of writing a code that involves the new operator on a hard-coded class name, is going to call the clone method on the prototype. The intent of this design patterns, the prototype pattern design pattern is used for creating a new object instance of by calling other objects. The prototype pattern delegates the clone process of the actual object that are being cloned. The pattern declares a common interface for all objects that support the cloning. This interface lets you clone an object without coupling your code with the class of the object. And if we're talking about the motivation of this design pattern, a prototype is a template for any object before the actual object is constructed. Prototype design pattern is used in a scenarios where application needs to create a number of instance of a class which has almost same state or like slightly different. So this pattern involving implementing the prototype interface which tells to create a clone of the current object. This pattern is used when creating an object is costly. For example, an object to be created after a costly database operations, we can catch the object, return the clone the next request and update the database as and when needed, which will reducing the database calls. The advantage of the prototype design pattern. Those advantages we can put them in some point like its high complexity of creating object. The client can get a new object without knowing which type of object it will be. Adding or removing instance at runtime, reduce the subclassing. Prototype pattern lets you clone a prototype instead of asking factory method to make a new object. It is used when there are numerous potential classes that you want to only use if needed at runtime. Also, there is a consequences for the prototype patterns. For example, hide the concrete products classes from the client. Overkill for projects that use very few objects. It's built on the method .clone, which could be complicated sometimes in terms of shallow copy and deep copy. Moreover, classes that have circular reference to other classes cannot really be cloned. The noun structure for the prototype patterns, it's look like this. So we will have a client with the operations, then we will have like an interface we use for the prototype patterns, then we're gonna have some concrete prototypes, maybe 1, 2 or more, and this gonna be subclasses of the interface, and those gonna return a copy of what the client we're gonna give them. So the prototype like interface for the clone and object, prototypes like greetings returns a copy of the products object. Also the concrete prototype classes implement the prototype interface by creating a copy itself, then send it back to the customer or save it. I use or I made UML class diagram, and so I use like something for animals. So we will have a prototype demo over here. Then we're gonna have clone animal. This is like a factory for clone. What do we need? This is the interface for our application, and we have two subclasses that belong to the that's under the interface. Like if this is animal, we have dog and cats under this one. So basically what gonna happen here, the client's gonna give us like gonna ask to create a clone. Also we'll give like an object. This object may be a dog or a cat, and this object will have to pass through the animal. That is like the main, and like when it's passed through the interface, it's gonna assign and use this and call this method, the make copy. It's gonna copy itself, then the result is gonna be sent to the client. So let's go to the code and explore it deeply. I create this code. They have few classes. I'm going to start with the animal, which like the interface. First of all, like it's an interface, animal, extend, clonable, which like making this class clonable, yeah, and letting you Java that's if this class will be able to copy instance of this class. Then we will have like one method inside. We were gonna call it like animal make copy. Then I create two subclasses or classes, like one of them cat, one of them dog, which basically the same thing. So I'm gonna explain cat, which is gonna have the same functionality. All right. So we will have a class. I call it cat, which implement the animals, and of course, as it implement this interface, it will have it's gonna override this method, which like right here. But before we go there, I made this constructor over here, and I make it print out cat object created because I wanted to tell us when the object called or created in this application. Then we're gonna override the make copy, which is gonna do like the main functionality or the main reason for this, which gonna like gonna system out like cat colon is being created. This is what's gonna print out to see if we arrive to this point. And of course we will have try and catch because here we're gonna call the animal superclass clone by this one. After that we're gonna cast it to the class we want or to the object. Like in this case we have a cat, and in this case we have a dog, and that's related to the superclass in animal. If the animal don't extend clonable error, so like it is not like this one, I mean clonable, this error will catch that and throw it. Then we will return our object. After that, I added here toString method, just like to show the difference if they call the actual object to the screen. So in dog, it's the same thing. We will have the first constructor tell us like this object arrive in this point. Then we're gonna override the make copy, which is gonna do like when we use it, it's gonna make the main thing inside this this method. Then we will have toString, and I type like Hachi is my good boy. Now let's move to the clone animal, which like the factory for this clone. This basically will receive any animal or animal subclasses and make a copy of it and store it in its own located in the memory, which like the main basic stuff we have to do here. Animal get clone, we're gonna create a type animal symbol because we got this one animal over here. After that we will have animal symbol dot make copy, which is like the main method inside the interface, and also it is right here inside the cat and the dog up to that one. So if we go to the demo right here, we're gonna this is like it's like the application, so it's gonna we will have here to create our animal clone, which will handle the making of the copy method calls for the right subclasses. Like I will call it animal maker, and then I will gonna assign some instance for the dog and cat. I call for the dog Hachi, for the cat Lolo. Then I create a clone right here. This is gonna create like a clone for everything about dog and cat and store it in its own place in the memory. After that, two profits in different memory, I added those two or four methods, which like toString right here. So if I run it, let's see what we're gonna get. Here we go. We got dog object created, then dog clones being created. Then I got Hachi is my good boy, Hachi is my good boy, and also for the cat. I think that's all, and thank you so much.